review, which is linear systems of equations. Okay, so the first page you'll notice has a lot of graphs. Okay, what we have to understand with linear systems is when we're finding a solution, graphically, it's the point of intersection. Okay, so looking at these three graphs in number one, only one of these I see an intersection of two lines. Okay, and that's this one on the far right. Okay, so in this one, there's an intersection right here. Okay, that has a solution. That's the solution. Okay, so this graph on the far right has one solution. Okay, because this is asking which one has one solution. The others will either have no solution or infinitely many solutions. When the lines are parallel, like this graph on the left, these are parallel lines, okay, meaning that they will never cross. So there is no solution because the solution is the point where the lines intersect. So this one has no solution. And then this one in the middle looks like it's just one line. If it looks like one line, you don't see a second line, it's because the second line is right on top of it. Okay, so these are actually the same line, the two equations that graphed here. So that means they don't intersect at one point like this one. They're on top of one another, so they're constantly intersecting because they are one and the same. So that's why there are infinitely many solutions. Okay, so those are the three possibilities for all of our linear systems. There's either one solution, and the solution is the ordered pair of that point where they cross. There's infinitely many solutions if they're the same line, or there is no solution if they are parallel lines. Okay. In number two, it's just asking us to state the solution. I can see in both of these are two different lines intersecting. So it's just finding the coordinates. Remember, a solution is an x, y coordinate. So this point is where? What is the x, y coordinates of that point where they intersect? Here's the origin. So the x value is -4, and then it's on the x-axis. So that means you haven't gone up or down any. So the y value is 0. So that intersection, that solution is at -4, 0. For this one, that intersection is not on an axis, okay, but I still need to get the x and y value of that point. Okay, so from the origin, that's left 6. So the x value is -6. And then that's down 2. So the y value there is -2. So again, this is just making sure you understand a solution is an ordered pair. It's a point where the lines cross. You need an x value and a y value. Unless it's one of these special cases where there's no solution or infinitely many. All right, in this one, it's asking which graph shows the solution to the given system. So this is understanding what the graph of a line should look like, okay? So when we go to graph to solve, we want the equation in y equals mx plus b. Because remember, when we have our equation in this format, y equals mx plus b, we can see the y-intercept and we can see the slope. Remember, slope is your rise over run. So I want these equations over here. I want these to be written as y equals so I can see which graph it's supposed to be. Okay, so for this first equation on top, if I was going to solve that for x, let me write that one out. Or excuse me, solve for y. I would move the x by subtraction. I cannot combine the -1 and the negative x. One is a variable term, one is not. So it just stays negative x minus 1. And then I have to get rid of the negative in front of the y. So I divide by -1. So everything gets divided by a negative, which changes it to positive. So that negative x divided by -1 is positive x. And -1 divided by -1 is positive 1. So that's just y equals x plus 1. So that means it has a y-intercept of 1. I don't know why it's making this hard to highlight. So the y-intercept should be 1 for one of these lines. So looking at the y-axis here in the first graph, here's where y is 1. None of our lines go through there. So that answer choice is out. Okay, oh, here, this one has a y of 1, but then your slope should be a positive 1. This one has a negative slope. It's going down from there. So that's out. That's not it. Okay, this one has a y-intercept at 1. That's good. And then it should have a slope of 1. So up 1 over 1. Up 1 over 1. Up 1 over. So this one checks out for the first line. That one has the first line graphed correctly. That's a good sign. And then this one over here, I can't even see the y-intercept. It's cut off. So I'm not positive but I can see this red line that I just checked that should be there. That's definitely, there's not even a line here that has a positive slope. Both of these lines have a negative slope. So that one's out. So it must be C. Okay, so you have to get your equations into y equals so that you can see which graph is correct. Okay, we don't have to bother checking the other one because only one of these had the first line correct. Okay, but if you had it narrowed down to say 2 options, you could then check the other equation. All right, on number 4, it's state which method, substitution or elimination, would be best for solving each system below. So graphing was one way that we learned to solve, but substitution and elimination are what we focused on this unit. So substitution happens when you plug another number in. Okay, or an expression in for one of the variables. So if you have one of the variables already set equal, so you already have y equals or x equals, that's when you're going to use substitution. So looking at this equation, y equals 2x plus 5 could be substituted in for y here. So this one should use substitution. It's set up nicely to use substitution. Okay. Elimination is when we have our x, y's, and constants all lined up. Okay, so you can see we have our x's set up together, we have our y's lined up, and we have our constants lined up. Okay, so when it's set up that way, that's when we're going to use elimination. Because this is where we go to add or the two equations and see how we have negative y and positive y, and they end up eliminating. And you eliminate one of your variables and then finish solving for what's left. Okay, so you should know what the setup is, which method is easier for that problem. Okay, so on the back, we actually get into solving. So 5 through 8 are actually just solving the systems. So we have to decide, is it going to be better to use substitution or elimination, and then we're going to solve. with number 5, it is already set up where the x's are aligned, the y's are aligned, the constants are aligned. And look at your y values. You've got negative and positive 2y. So those are going to eliminate when I add these equations together. So negative 4x and positive 5x is just x. And then 6 and negative 11 is negative 5. And there's nothing left to solve. X is negative 5. So now I take that and I plug it back in to one of the original equations. It doesn't matter which one. I will just use the 5x minus 2y. You can pick either of the original equations. And we're going to plug in for the x. We said x is negative 5. Okay, so we plug in here because that's what we got over here. So 5 times negative 5 is negative 25. And then I'm ready to solve for y. So I'm going to move that 25 over by addition. So I can combine negative 11 and 25 to get 14. And then I'll divide out the negative 2 coefficient. And I get negative 7. So I get an x and a y. So I write it as an ordered pair, x, y. That is the point where those lines would cross if I were to graph them. Okay, now in number 6, this one's also set up for elimination. I'm just going to put an E or an S out to the side for elimination or substitution. So here we did elimination. Here we're going to do elimination as well. Okay, now they don't eliminate yet. We have to do something first because they're not complete opposites. So if I want to eliminate my x's here, this is a positive 6 and a positive 3. I would need to multiply by negative 2 because that would turn that into negative 6x. But I have to multiply everything. Everything gets that negative 2. So that becomes positive 2y. And that becomes negative 12. Okay, now the second equation, I didn't touch, so it just stays exactly the same. I'm going to add these together. What happens to the x's? They eliminate, right? That was the goal. Negative 6x and positive 6x. But look at what also happens to the y's. Negative 2y and positive 2y also eliminate. So there's nothing left on the left side of my equation. It's a 0. Now on the right side, those do not eliminate. That ends up being negative 22. When this happens, these are those two special cases we talked about on the front. If your x and y both are gone and you're left with just a number equals another number, we said it either means there's no solution or infinitely many solutions. Okay, and you determine whether or not this is true. Do you get a number equal to the same number? Okay, is it a true statement? This one is not true. Okay, 0 is not equal to negative 22. That is false. It is not true. So that means that there is no solution here. Now, number 7, this one is set up for substitution because we've got y equals. So I'm going to substitute that in for y there. So this is going to be negative 10x plus 2. And then instead of y, it's 5x plus 7 equals negative 14. Now I'm going to simplify. I'm going to distribute this plus 2 that's being multiplied by the parentheses. So I've got negative 10x. That becomes plus 10x plus 14 equals negative 14. So here, what happens when I simplify? 10x and negative 10x eliminate. So I am simply left with 14 equals negative 14. Is that true or not true? Are 14 and negative 14 the same thing? No, one's positive and one's negative. They are not equal. Okay, just like that last one. So there is no solution. If it had said 14 equals 14 or negative 14 equals negative 14, then there would have been infinitely many solutions. Okay, but the way this one worked out, there's no solution there. All right, 8 is also set up nicely for substitution. Okay, y equals, so I'm going to replace y with that expression. So this will become 5x minus 4, and then instead of y, it's negative 3x plus 5. That equals negative 3. So on this one, when I distribute this negative 4, okay, 5x in front doesn't change. This becomes plus 12x. That becomes minus 20. And now I can combine like terms here. 5x and 12x is 17x. And then I can start moving terms to solve for x. All right, we'll continue going over these after lunch. Okay, this is 17. When I divide out that 17, I get 1. What? Okay, I'll look at it when y'all come back from lunch. All right, so here, once you have x is 1, then we can go and plug it back in to where it said y equals negative 3x plus 5. X is 1. So negative 3 times 1 is negative 3. Negative 3 plus 5 would be positive 2. So now I've got an x and a y, so I write my solution as 1, 2. All right, I'm going to stop this video here. I'll go over the rest of the review in the separate video.